Hello everyone, today we are going to start the next part of electricity chapter, that is the part 3. Here we'll learn about the heating effect of current and electric energy. When electricity passes through a high resistance wire, like a nichrome wire, the resistance wire becomes very hot and produces heat. This is called the heating effect of current. The greater the resistance of the wire, the greater the amount of heat produced. James Prescott Joule studied the nature of heat and discovered its relationship to mechanical work. This led to the law of conservation of energy, and this led to the development of the first law of thermodynamics. He found the relationship between the current through a resistor and the heat dispatched, which is now called Joule's first law. Let an electric current I is flowing through a resistor having resistance equal to R. The potential difference through the resistor is equal to V, and the charge Q flows through the circuit for time t. Then the work done in moving the charge is V into Q. Therefore, the source must supply the energy equal to the VQ in time t. So, the power input to the circuit by the source is P equals to VQ by T, and hence P equals to VI. Since the electric energy is supplied for time t, thus after multiplying both the sides of the equation by t, we'll get Pt equals to VIT. Thus, for steady current I, the heat produced in time t will be equals to VIT. According to Ohm's law, we know that V equals to IR, and hence H equals to I square RT. So, the law implies that heat produced in a resistor is directly proportional to the square of the current for a given resistance. Secondly, it is directly proportional to the resistance for a given current R, and it is directly proportional to the time for which the current flows through the resistor. Therefore, H proportional to I square from the first point. From the second point we are getting H proportional to R, and from the third point we are getting H proportional to T. So H proportional to I square RT. Now the practical application of heating effect of electric current. We are using this heat due to the flow of current in our daily life, as in electric iron, electric bulb, electric fuse, electric heater, and more. In electric bulb, we are using the heating effect of electric current, and in this case we see a thick metallic wire in the bulb. It is made up of tungsten metal, and in a glass vessels or bulb the tungsten wire is kept sealed. The glass vessel is filled with neutral gas or vacuum. Neutral gases are using nowadays commonly, and the tungsten wire is known as the filament. When the current flows through the tungsten wire or filament, it becomes heated and emit off light. Due to the flow of current, heating effect of an electric current used to source of light. Electric iron. In an electric iron, the upper part is grooved. In this groove, a coil is placed. Mica as an insulator is placed between the metal part and the coil, so that there is no electrical connection between the. Mica is a bad conductor of electricity, but it is a good conductor of heat. Due to the flow of current through the coil, it becomes heated and the heat transferred to the metal part through the mica. Finally, the metal part becomes heated and it is used the heating effect of electric current. Electric heater, it is also an application of heating effect of current. In an electric heater, one type of coil is used which has high resistance materials like nichrome or some type of material is used in this coil. The coil is wound in the groove on ceramic format or a china clay, and flowing the electric current through the coil, it becomes heated. Due to the high resistance, the coil becomes red color flame. Electric fuse, it protects the circuit and appliances by stopping the flow of any unduly high electric current. The fuse is placed in the series with the device and it consists of a piece of wire made of a metal or an alloy of appropriate melting point. A electric kettle use both the copper and nichrome wires, where copper has a low resistance while nichrome has high resistance value. When nichrome wire is used in the heating element, as it has a high resistance value and produces a lot of heat. Electric power, it is the electric work done per unit time, that is P equals to W by T. Its SI unit is watt and 1 watt is defined as the rate of working of 1 joule per second. Electrical energy, it is the total work done by current in an electric circuit. Work done by electric circuit equals to electric power into time taken, that is E equals to P into T. Its unit is watt hour. 1 watt hour is the amount of electrical energy consumed when an electric appliances of 1 watt power is used for an hour. Its unit is watt hour. 1 watt hour is the amount of electrical energy consumed when an electric appliances of 1 watt power is used for an hour. Thank you everyone. Have a nice day.